Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Today we will continue talking about conditional probability. Let's begin. Let's see this activity. We have this table: boys, girls, humanities, LS, ES. One student is selected randomly from the school. We have the events H, L, E, and B. We saw this table before. The question is to calculate P of B intersection H, P of B intersection L, and P of B intersection E. Well, for P of B, we need the probability of selecting a boy. Boys are 47, and they are 47 out of 100. Now, P of B intersection H, which is the probability of selecting a boy and a student in the humanities section. So it will be this number, which is 15 over the total, which is 100. And then P of B intersection L, it will be 12 over 100. And similarly for B intersection E, which is 20 over 100. Now the question is, what is the relation that exists among P of B, B intersection H, B intersection L, and B intersection E? Well, we have 47, we have 15, 12, and 20, and we can easily see that P of B is B intersection H, B intersection L, and B intersection E, and this is very logical because if we think about it, what is the probability of selecting a boy? It will be the probability of selecting a boy from the humanities section, or a boy from the LS section, or a boy from the ES section. Now let's continue. Calculate P of L intersection B and L intersection B bar. Let's see what is the probability of choosing an LS student. The LS are 30. It will be 30 over 100, which is 0.3. And then the probability of L intersection B is the probability of selecting a boy from the LS section. That's it. So it will be 12 over 100. And then L intersection B bar. Remember, B bar here means that the selected student is not a boy, consequently it's a girl. So the probability of selecting an LS student and a girl, which is somewhere here, it will be 18 over 100. Now also we need the relation that exists among the three probabilities. We can also see that 0.30 is 0.12 plus 0.18, so P of L is P of L intersection B plus P of L intersection B bar. This is also logical because the probability of selecting an LS student is the probability of selecting an LS boy or an LS girl. Now let's see the results of activity 2. A is an event in a sample space omega such that omega is distributed as A1 union A2 union blah 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 union AN, and the intersection between any two A's is phi, and B is another event in omega. We can say that the probability of B is the probability of B intersection A1 plus the probability of B intersection A2 plus blah 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 plus the probability of B intersection AN. And each probability of these is going to be written in another form using conditional probability. Let's see an illustration about this formula. If this is omega, and this is set A, and this is another set B, well, this would be A bar, and this would be A intersection B or B intersection A, and the purple part would be B intersection A bar. So the purple part is the intersection between B, the red set, and A bar, which is here. So it will be B intersection A bar. Now from here we can say that the probability of B is the probability of B intersection A, which is the green area here, plus the probability of B intersection A bar, which is the purple area. So the probability of B, the whole B, is going to be B intersection A plus B intersection A bar. And this is also could be written as B given A times A plus B given A bar times A bar using the conditional probability property. Now, what are the formulas that we should know so far? A and B are two events of the same sample space. We should know that P of A plus P of A bar is 1 and its consequences. P of A union B plus P of A intersection B is P of A plus P of B and its consequences. We should know that P of A given B is P of A intersection B over P of B, and that P of A intersection B is P of A given B times P of B. And we should know the rule of total probability, which is P of B is P of B intersection A plus P of B intersection A bar. Now, this is the list of properties that we should know so far. Remember their consequences. Let's see this example. M and N are two events such that P of M is 0.1, P of N given M is 0.2, and P of N intersection M bar is 0.27. And the question is to calculate all of these probabilities. Let's begin. We know P of M, we need P of M bar, so we apply the first property here. P of M bar is 1 minus P of M, which is 0.9. Now we need P of M intersection N. We know the conditional and we know M. So what is M intersection N? Applying the third property, it's N given M times M, which is 0.2 times 0.1, which is 0.02. Now one might ask, why didn't we use the property P of M given N times N? In fact, this could have been used if it were given. Now, what is the probability of M intersection N bar? Also, we know till now 5 probabilities, so we could see from here that M intersection M bar to be calculated. We use the total probability. What is the probability of M? It's M intersection N plus M intersection N bar. So this is the unknown, and we know P of M, which is 0.1, and P of M intersection N, which is 0.02. Now we need P of N. What is P of N? It's N intersection M plus N intersection M bar. We know N intersection M bar from here, and remember that N intersection M is the same as M intersection N. So this would be the answer. Now we need P of M given N. Applying the property of conditional probability, M given N is M intersection N over N. We know both of them. We just substitute. We get 2 over 29. And finally, M given N bar, we also use the rule of total probability. And this would be the final answer. Now let's see this application. A and F are two events of the same sample space. We need to match. Try to think about the probability of E union F among these properties. So it's very clear that P of E plus P of F minus P of E intersection F. Now try to find the second rule. Till be P of E, applying the total probability rule. Now try to see 1 minus P of E. It's P of E bar using the first rule here. And try finally to find the probability of E given F. So it will be E intersection F over P of F. Now let's see the second application. S and L are two events, and this is what we know. And the question is to calculate each of these probabilities. Try to begin working with the first probability. What is the probability of L intersection S? Well, here we can see that the intersection could work from the second rule or from the third one or from the fourth one. Now, which one do we choose in order to calculate? It depends on the given. So what is the probability of L intersection S? It's the probability of L given S times the probability of S, and by substitution we get 0.12. Try to see the second one. So similarly here, the probability of L intersection S bar is the probability of L given S bar times S bar, and we know the probability of L given S bar, and we know that the probability of S bar is 1 minus the probability of S, and this is what we get. Now the probability of L, after knowing all of these properties, it's clear that the probability of L is L intersection S plus L intersection S bar. So we use these two results in order to get 0.26. Now, for S given L, if we just apply the property, we get S intersection L over L, and we know S intersection L from here, which is 0.12, and L from here, which is 0.26. Now try to see S intersection L bar. So S intersection L bar is P of S minus P of S intersection L. Applying the total probability rule, it will be 0.18, and try finally to find the probability of S given L bar. It will be S intersection L bar over L bar. By substitution, this would be the final answer.